Okay, so hopefully you've figured it out. For number one, the 20 ounces of iced tea is the parameter, and 19.6 ounces of iced tea is the statistic. Now, it says here that the Arizona iced tea is supposed to be filled to 20 ounces, right? So the reason why that's the parameter is that's the assumption of what the population mean is for the amount of iced tea filled in each of the bottles, right? And then you take a sample of 50 bottles, and that has a mean of 19.6. That would be considered the statistic, okay? For number two, same type of thing. The 10% of passengers at the airport is the parameter, and 8% of the 125 passengers is the statistic, because it says 10% of the passengers at this airport, right? So that's the entire airport, which means that's the parameter, and the 8% of the 125. Since 125 is your sample of the population, then that is the statistic. So hopefully that was easy to understand. And yeah. All right. So let's move on. So let's talk about sampling variability. Okay. Now, when you take multiple samples from a population, the question a lot of times, the question is my sample a representative sample? And even if you take a sample, a simple random sample or stratified random sample or cluster sample, like proper sampling methods, like we don't know whether our sample is representative of the population or not. And the reason we don't know is because of this, is because of sampling variability. Okay? So in other words, every sample is different, right? When we take samples, they're all different, right? And to illustrate this, I'm going to have a very large deck of cards. Okay, so I have a very large deck of cards here. Hopefully you can still see this properly. And I'm going to take multiple samples of 20 from this card deck. Normally, I would use chips, like blue and black chips, but I don't have those, so we're going to use red and black cards. And then hopefully you'll be able to make the connection. So assume that this deck of cards is really, really, really huge. I've tried to make it, really, really big. I've combined multiple decks, and I've shuffled each of them. So hopefully, this is, when I draw from the top here, it would be considered random. Okay, so to illustrate sampling variability, I'm just going to take a sample of 20 cards real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, here's 15, and this is my lame attempt, okay, of a good example. So let's count them. Okay, so let me fan it out for you to take a look. I'm going to count them real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wow. That's crazy. Okay, so here's the fan out. Okay. You can count them yourself if you would like. But in this sample right here, right, in this sample, there are actually 10 black cards and 10 red cards, right? So the sample value of p hat, which is what we're going to call it, is 0.5. Now, this population here, right, this population should be 0.5 as well. Now, in this case, we know our p hat, or, technically we don't know, because you don't know if I've rigged this deck or not. But we know that this represents the sample pretty well. okay? Or represents the population pretty well. So I'm going to take another sample real quick, okay? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, hopefully what happens is what I want to happen. But since this is, you know, pretty random, it might not. So let me count real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's crazy. It didn't happen. Half black, half red. Again, that's actually crazy. All right, so what I'm trying to illustrate is that each sample, the more samples we take, the more variability there's going to be, but I just took 2 samples from our population and they were the same. 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so hopefully... Okay, I'm pretty sure it happened this time. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so take a look at this sample right here. Okay. Alright, now in this case I have 13 black cards and 7 red cards. Okay. And so these 3 samples, these 3 are 3 separate samples of the population of cards, right? And there's going to be a variability, and obviously the first 2 represented the population well, and the last one, you know, 65% is the P, right, for black cards, right? Is the P hat, right? And we know that the population is supposed to be 0.5. So obviously there's a small issue there with that. Okay. So so that's sampling variability. Essentially, is like if I take a lot of samples, all of the samples are going to be different. And how do I know, essentially, which sample represents the population? Okay, does my sample represent the population well? And what should I do? And some of you may have already guessed what we should do, but we'll get to that in a moment. Okay. Oh, actually, here it is. So, now this is something that we would normally do in class, right? But essentially, I did it with cards instead of with chips, right? Normally, what we would do is we would take, you know, a bucket of chips that has a certain number of red and a certain number of blue in there, and you would grab 20 chips and then tell me the number of chips that you have within your sample, okay? Or so what proportion are red or what proportion are black. In this case, or red versus blue. In this case, it would be red versus black, okay? And here, this is the distribution of all of your samples, okay? And this is an estimation of what we call the sampling distribution. Okay? Now, I know that this is a little confusing, but the point is, right here, this means that there's one person in the class that got a sample that was 20% red and 80% black. And there were 7 people in the class that got samples that were 50% red and 50% black. And right here, there were 4 people in the class that got 65% red and 35% black. Now, this is under the assumption that it's half red, half black. Or, sorry, blue. They're using blue here. But since I'm using cards, it would be black, right? So yeah. So all of those samples, if you take them and you create a distribution of all of these samples, of all the possible samples, that would be your sampling distribution. This is only what you see here. Wrong way. What you see here is only an estimation of what my true sampling distribution is. Okay? And my true sampling distribution is going to have all the possible samples that you could collect from a population containing half red and half blue chips. Okay? And in this case, cards that I'm doing. Okay? So hopefully I can illustrate what this is. Now, yeah, so here, I should have went to this slide earlier, okay? So, in theory, the sampling distribution is collecting all the possible samples of a particular size. In this case, it's going to be 20, from some population, right? We took samples of 20 of these cards, all right? So, the difference between these three, okay, we're gonna talk about that now. The population distribution gives the value for all of the individuals in the population. The distribution of your sample data shows the values for all of the individuals within your sample. Now, the sampling distribution shows all the possible statistic values of possible samples of the same size from the population. I know that's confusing, but when I show you a picture, hopefully it'll make sense. Okay? So here, this is a picture. Let me hide myself so that you can see. So here, if you take a look at this, the population distribution here is red and blue, right? And you can pretend this is black if you want. Because we assume that half of these are red and half of these are blue/black, okay? So the parameter is 0.5. Now, when I take my samples, they could be different, right? This is 40% red, 55% red, 65% red. When I put all of those possibilities together in a distribution, that is my sampling distribution. Okay? This is the proportion of samples that would be 50% red. This is the proportion of samples that would be 45% red, so on and so forth. Now, take a guess as to what the mean of this distribution is. That's right. It is the population parameter. So you guys probably guessed that. I don't know if you did or not. But whatever the mean of this, as long as my samples are unbiased, it should get me the population parameter, whatever that may be. All right. Hopefully that was clear. If it's unclear, read your book, send me an email, and I will see you tomorrow in another video. Deuces.